Welcome back, and we're on to the 20th of January. So another mix of 5 questions for us to do today, and let's get started with the first one. Okay, so the first one, so the first one gives you the nth term of a sequence. I thought it was going to be a limiting sequence question, but it's not. The nth term of a sequence is this. Work out the position of the term that has a value of 0. Okay, all right, so in other words, I want to know for which value of n do I get 0. Now, I've made this comment in other videos as well. It doesn't matter what number I have on the bottom, except for 0, ironically. In order to make the overall thing 0, the numerator needs to be 0. And that is because 0 divided by anything is always 0. So in other words, I know that 1260 minus 15n must be equal to 0. So n equals 1260 divided by 15, which is going to be, to check my calculator, 84. So UN is equal, U84 is equal to 0. Next question. Good question, that. Next question. Oh, there we go. Write down the limiting value. I thought this might come up of the sequence. Now, as you may have heard me say before, if I have 1260 minus 15n over 1260 plus 15n, if n is a very, very large number, a trillion, well, 15 trillion add a little bit or minus a little bit is basically minus 15 trillion. In other words, the number doesn't really matter. And 15 trillion add a little bit is still 15 trillion. So really, it's approximately, for large values of n, 15n divided by 15n with a negative, which is the same as minus 1. So the answer to this one is minus 1. And again, in an exam, very, very large number, put it in your calculator. It doesn't feel like it should, but it would give you minus 1. We say it approaches minus 1, so it's a limiting factor. Next question. F of x equals x plus 1, x plus 3 for all values of x. So we have a quadratic right down the range. Okay, all right. A few ways of doing this. You could expand, you could do it various other ways. I'm going to use my understanding of quadratic. So I know that my roots are minus 1 and minus 3. And of course, I've got that from here. So if I map that on my graph, that's minus 3 and that's minus 1. Now we know from quadratics they are symmetrical. So therefore the number in between, which is minus 2, is going to be where my turning point is. And if I put minus 2 into f of x, in other words, f of minus 2 is equal to minus 2 plus 1, which is minus 1, and minus 2 plus 3, which is 1, which is equal to minus 1. So my turning point is minus 2 minus 1, which means my range, you've got to be careful here because you need to write f of x, so f of x is greater than equal to minus 1, and again greater than equal to because I can get to minus 1. Good question. All right, find the exact values of w. Now the fact it said exact values suggests to me that we're going to get some slightly complicated quadratic here, so let's see what happens. So let's fix these all to be, I'm going to zoom in a little bit so I can see it better. So let's fix these so they're all powers of 3. So I've got 3w squared equals 3 squared, which is 9, times by 3 cubed. So multiply this by 3, so 3w plus 15. So 3 cubed is 27, and then I've just expanded the bracket to give me 3 times w plus 5. Then I can do this as one big function, so therefore w squared is equal to 2 plus 3w plus 15. Okay, now I see what its exact values. So therefore w squared minus 3w minus 17 is equal to 0. You can't factorize that. No, you can't. So therefore I must use the quadratic function. So therefore w is equal to 3 plus minus the square root of 9 plus 4 times 17, which is 68, and divide all that by 2. So let's see if we can tidy this up. So 3 divided by 2 doesn't really work, so we'll leave it like that. So it's going to be 3 over 2 plus minus, sorry, I'm pausing to just check I've written that correctly. Yes, I have. 3 over 2 plus minus 68 plus 9 is going to be 77. So plus minus a square root of 77 over 2. And that is that question done. Okay, final question. Given 2 to the power of 89 minus 1 is prime, show that it's a multiple of 3. Okay, I'm going to think about this question for a second. Well, my temptation is to think difference of two squares because of that, but then 89 over 2 doesn't divide properly. Oh, I know. Okay, this is a A-level question that comes up every now and then. Not this sort of question, but it's about understanding what a multiple of 3 is. If I have 3 consecutive numbers, it doesn't matter where those numbers are, it must be the case that one of those numbers is divisible by 3. Now, I know that 2 to the 89 is divisible by 2 and not divisible by 3. So that's not divisible by 3. Can't be, because it's all 2's as prime factors. It tells me that 2 to the 89 minus 1 is prime, so that is not divisible by 3. So that means it must be the case that this number here is divisible by 3. And this number here is 2 to the 89 plus 1, not 2 to the 89 plus 1, 2 to the 89 plus 1, and so therefore that must be divisible by 3. Now I will say that's not a proof you'd write down quite like that in your exam, but it would say something like shows understanding that 3 consecutive numbers, etc. Good question. I like that question at the end. It's quite a difficult question. Got me thinking a little bit. As ever, usual thing, any comments below, like, subscribe, and I'll see you for the next one. Thanks all.